So let's look at an example, a very simple one. Here, two unbiased coins are being tossed. And you know when you toss a coin, you have only two possible outcomes, heads or tails. So the first part of the question asks us to draw a tree diagram showing all the possible outcomes. We have two coins being tossed. So we can break this down into two actions. You say, okay, I toss the first coin, and I can get heads for the first coin. So this one refers to the first coin, and I can get tails. So that's what this represents, the first coin along this line. Next, we're tossing the second coin. You can get heads on the second coin or tails on the second coin. Or if you got, so this is a scenario where when you toss the first coin, you get heads. So when you toss the second coin, you either get heads or tails. Here we're saying, I'm considering a scenario where after the first coin toss, one gets tails, and then one gets either heads on the second coin or tails. Very simple tree diagram, but it's not complete because it needs to be labeled with the probability. So this line here, moving the cursor over, just represents the second coin toss. So let's think about it with a different color. What's the probability of getting heads on the first coin toss? Simply 1/2. What's the probability of getting tails on the second coin toss? 1/2. What's the probability of getting heads on the second coin toss? 1/2. Probability of getting tails on the second coin toss is 1/2. What's the probability of getting heads on the second coin toss? 1/2. Probability of getting tails on the second coin toss is 1/2. So this is a really simple diagram. The key thing here though is the probability here, that is the probability of getting heads on the second coin toss, given that heads was obtained on the first coin toss. As you know, the result of the second coin toss is not affected by the result of the first coin toss. And that just shows that the outcomes of the two coin tosses are independent. So here, I'll just circle this in blue. This probability is the probability of getting heads on the second coin toss, given that heads was obtained on the first coin toss. But because the coin tosses are independent of each other, this probability is simply this. So you might need to review the idea of independent events for this to make sense. Just look at the video covering independent events, and this will make perfect sense. Here, what we have here is the probability of getting tails on the second coin toss, given that heads was obtained on the first coin toss. Again, because the events are independent, it's simply the probability of getting tails, which is why it's just 1/2. Here, we have the probability of getting heads on the second coin toss, given that tails was obtained in the first coin toss. And that's simply probability of getting heads on the second coin toss, because the coin tosses are independent. The outcome of the second coin toss is not affected by the outcome of the first one. And finally here, this probability is the probability of getting tails in the second toss, given that tails was obtained in the first toss. And that's simply the probability of getting tails in the second toss, which is 1/2. So our tree diagram is complete. So now we need to move to part 2 and work out the probability of obtaining two heads. Okay, so here, the event we have, and you obtain these events by moving along the branches. is the event where you get heads from the first toss and heads from the second toss. So that's heads and heads. Here, for this second case, it's heads then tails. So heads in the first toss and tails in the second toss. Here it's tails in the first toss and heads from the second toss, tails from the first toss, and tails from the second toss. So we're asked to find out the probability of obtaining two heads, and that's simply the probability of this event. The probability of heads and heads of this event, two heads. There's only one way you can get two heads. These are all the possible outcomes, this, and that. And it's only one of them has two heads. And you simply obtain that by multiplying along the branches that allow you to arrive there. So it's half times half, which is 1/4. So that's probability of obtaining two heads. In the third case, we need to determine the probability of obtaining at least one tails. At least one tails. So this is tails. There's one tails here. There's one tails here. There's two tails here. So that's the probability of this event, or this event, or this event. So if I just call this event, what I'll do is let this be event 1, let this be event 2, let this be event 3, and event 4. So this is part 3. The answer is the probability of 2 or 3 or 4. That means it's the probability of 2 plus probability of 3 plus the probability of 4 minus the probability of 2, 3, and 4. Or rather, twice. In order to avoid complications, just from the diagram, you can see that it's the probability of this, this, and that. Don't worry about the subtraction, because that will add confusion actually. There are only 4 possible events, and to get at least one tail is either this, this, or this. And because these events are mutually exclusive, they can't both occur, you simply add. Remember, if you have events that are mutually exclusive, the probability of, if A, B, and C are mutually exclusive, the probability of A or B or C is simply obtained by probability of A plus probability of B plus the probability of C, which is what I've done here. Because these are mutually exclusive events, they can't occur together. You can't get heads and tails and then, heads, then tails, then get tails, then heads. You have to only get one. Anyway, you have to add up the probabilities. Now, what you notice is that the probability of this event is obtained by multiplying along the branches. But because, which will give us half times half, which is 1/4. That's what this probability is. But you notice that the probability of this event is also 1/4, and this is also 1/4 because you're just multiplying half by half, in each case, half by half. So it's simply 1/4 plus 1/4 plus 1/4, which is 3/4. So that's probability of getting at least one tails. Another way to work out the probability of getting at least one tails, because again, you know that at least one tails means getting tails greater than or equal to 1 tails. How do I put it? You're getting at least 1 tails. So you must have at least 1 tails. So what's the opposite of that? If you're not getting at least 1, it means you're getting none. Think about it. If you don't get at least 1 of something, you don't get at least 1 sweet, that means you get none, because you don't even get 1. So the opposite of this is, let's see, let me put it this way. If A is the probability, let's say A is getting at least 1 tails. At least 1 tails. Not A is getting no tails. No tails. That means the probability of getting at least, well, probability of A obviously is always 1 minus probability of not A, as you know. So the probability of getting at least 1 tails is going to be equal to the probability 1 minus probability of getting no tails, based on this definition. What's probability of getting no tails? Well, if you look at our sample space, we have 4 events: 1, 2, 3, and 4. Here we have we have 2 tails. We have tails here. We have tails here. Here we have no tails. So the probability of getting no tails is the probability of this event of getting 2 heads, and we already worked that out as 1 over 4. So probability of getting no tails is 1 over 4. So 1 minus 1 over 4 is 3 over 4. As you can see, the answer is the same. So there are 2 ways of working it out.